I have authored I don't know how many papers now in peer-reviewed journals. I think four or five.
Hmm.
So
I went
I'm
through
not,
one of
but
your ones on animal suffering today.
right, yeah.
I
Oh,
saw some of that.
okay, good, good.
Yeah.
Yeah.
Uh, you are a fellow of the Royal Society. That
Uh,
how do you do that, Phil?
no,
That's pretty cool.
Royal Astronomical
Royal
Society.
Astronomical Society, which is
Yeah,
that a sub?
it's one step down from the Royal Society.
Okay,
Being
okay.
a fellow of the Royal Society is really something.
Yeah, yeah, yeah.
Very few get to do that.
And I know
Um, yeah,
you
but
have
Royal Astronomical Society is still good. It's
yeah,
still
yeah,
good,
yeah.
but it's not quite
It's
at
not
that
quite
level.
the yeah, something to
Yeah,
strive for. But you have
right.
you do astrophotography
That's right. Yeah.
as a side hobby,
There's
and
some pictures that I've taken from my telescope in the book, actually.
yeah,
Has
yeah.
everyone read the book, by the way? I don't know. Like, I know there's
I
a book
can't
club.
guarantee that. I have 30 pages left to read,
Okay.
but
Okay.
I saw some of the pictures in there, and
Right.
that's a great book. I really enjoyed the books.
Thank you.
Well written.
Thank you.
I mean, I think you have to be a little bit interested in this topic to sort of grasp what's going on there.
Right.
But
Right.
anyway, let's talk a little bit more about what you're doing. You have a YouTube channel where which you put Christians and theists through the meat grinder of your with your professional philosopher friends. Um,
Yes.
you used to
Yes.
be a journalist in residence at Penn State Institute for Gravitation and the Cosmos. I'd never heard of that until I saw your bio. What is that?
Oh, it's well, it's an institute that does research in cosmology and fundamental
Okay,
physics, and but with an emphasis on gravity, so cosmology, stuff like
gotcha.
that. But specifically, it's also kind of the home for loop quantum gravity.
Okay,
So I had done some outreach for them, and they invited me to come over there. So yeah, it's kind of like one of the main bases for that kind of research for quantum
all right.
gravity.
Now
Yeah,
I I'll just tell everybody, and I know we go way back, sort of to 2019 when my book came out, The Story of the
yeah,
Cosmos,
yeah.
and Justin Brierley got a hold of both of us to have us
Oh
on the
yeah,
show. And I
yeah,
will tell you now, Phil, looking back 6 years later, I got scared. I started
yeah.
watching.
I figured you did. Yeah,
I I I did. I started watching your YouTube channel, and I was like, my gosh, this guy knows his stuff. And this was my first book. Still is my only book, and it was my first time, and I was going on the big stage, and I just wasn't. I don't think I was ready for it. So
that's okay. I figured as much. Yeah,
I
it's
uh
fine.
I
It's
will
fine.
publicly apologize here to you for that backing out because it was kind of last minute too. I kind of pulled a last minute. I think
It was, and I'd read the book and made notes on it, and I
you
was all
did,
ready to go.
and
And
Justin had it on his chart, and here I am in Texas. I just like, no, I'm not going to do it. I should have done. I should have put on the
but
man
I
pants.
understand. Like it's totally normal. It's human behavior. It's fine.
Yeah, I should have put on the man pants and just done it. I think it would have been fun. I think
Well,
it would have been a
well, we
fun
can have
time.
at it now.
We can have at it now. So we'll just we're at a distance, so there's no physical blows, but I'm sure you'll still run me through the grinder of your knowledge of cosmology and physics. But all that. Uh, Anything else you want to add to our brief back and forth introduction here, and then we'll just jump right into what's the book all about.
Yeah, no, I don't like blowing my own trumpet really. So yeah, let's just get into the book. Yeah.
Okay. Well, you've probably talked to a majority of living cosmologists today with your channel. You've talked to Roger Penrose, you've talked to Stephen Hawking, you've talked to Sean Carroll, and the biggest names in physical and theoretical cosmology that are out there today. And all of your videos and films and stuff are on your YouTube channel. We have in the links in the chat of our Zoom today, we have all of your information. We have your YouTube channel, and we have my book. There's chapters for our next club meeting, which I got to talk about that here in just a second. But if you check out the chat, everybody that's here, check out the chat, and you'll find the notes to everything for this month and next month. And while I'm on the topic of next month, we are going to see if I can get this to work. Next month, just to let everybody know, we are going to be featuring Dr. Casey Luskin from the Discovery Institute in Seattle, Washington. Casey is going to talk with us about intelligent design. He has graciously given us two chapters from this book, The Comprehensive Guide to Science and Faith. Free PDFs. They are in the chat notes. You can download those. We will put them up on the Friends of the Atheist Christian Book Club if you can't get them today, but they will be up on that. They're free chapters. You don't have to buy the book. These are going to be our focus chapters. Casey's going to talk to us about what intelligent design is, and a great guy. I met him in Colorado this past year. We hit it off. Really nice guy, a lot of fun to talk to. He's very energetic about his topic, and he has a wealth of knowledge about this topic. Whether you agree with him or not, I think you will enjoy meeting and talking with Casey. So that's coming up on our September book club, back to regular time on the 4th from 7 to 9 p.m. So that's next month. All right, Phil, I want to start off. Can you see my screen?
Yeah.
Okay,
Yes.
so you have talked at length to Sir Roger Penrose.
Yes.
I actually did an article for Justin Brierley when Dr. Penrose debated Dr. Bill Craig, just as a review of the debate. But I wanted to lead off with this quote because Dr. Penrose's conformal cyclical cosmology kind of fits this. And this will give you a platform to talk about your book and all the theories that are discussed in the book. This was in 2016, and I know Roger has changed his mind. He changes his mind quite a bit when he adjusts it to the evidence and the knowledge that's out there. But he says this, and it reminded me of how as I was going through your book. He says that there are some key aspects to the nature of our actual universe that are so exceptionally odd, though not always fully recognized as such, that if we do not indulge in what may appear to be outrageous flights of fantasy, we shall have no chance of coming to terms with what may well be an extraordinary, fantastical seeming underlying truth. And as I was reading your book, I was thinking about this quote because there are so many. This is not a criticism, it's just an observation that there are so many wonderfully strange theories about what may have happened
Yeah.
before. Can we say that now? Before the
Yeah,
Big
sure.
Bang?
No
Is
problem.
that
Yeah.
yeah? A
Yeah, it's
couple of
fine.
years ago, you were a little bit put in the the weird category for suggesting a before. But
Yeah,
now
yeah, yeah.
your
But
book is a robust exploration of the questions of what may have come before the Big Bang. So why don't you just jump right in, give us a 5-10 minute rundown, and we'll just open it up for questions and discussions.
yeah, sure. So actually the quote's quite appropriate. We have a similar quote by Penrose in the book because he criticized one of the mainstream theories about what happened before the Big Bang called inflation, and he called it a fantasy. But and the book that you're referring to is called Faith, Fashion, and Fantasy. And
Mm-hmm.
the fantasy is inflationary cosmology. But in this case, he wasn't really being pejorative. What he was trying to say was, well, whatever you come up with is going to be pretty fantastical. Um, so don't have a go at my model because it's fantastical. They're all going to be fantastical. Something strange happened 14 billion years ago, and our book, Battle of the Big Bang, is about what that might have been. So there was all kinds of ideas out there. Um, so the one that probably most people have heard of is called inflation. We can go into that in a minute, but there are all kinds of other ideas. Some of them are alternatives to inflation, and some of them are sort of prequels. But to give you a brief, sort of rough idea, we've got this idea of inflationary cosmology, which is an exponential expansion of the universe, which is thought to have happened now before the Big Bang. That's what we think now. When it was
Mm-hmm.
first marketed, it was thought to be happening just after the Big Bang. But now, actually, I think most people understand it as happening just before the Big Bang. But on top of that, you also have sort of what are called quantum cosmologies, where try to use principles of quantum mechanics to explain the origin of the universe. Then you have but those there are early versions of quantum cosmology proposed by Stephen Hawking and Alex Valenkin and scientists like that. But they didn't really use actually true theories of quantum gravity because they were done in the early 80s. So then we sort of our book actually starts off in in ancient Greece. So we
Mm-hmm.
try and give like the history of cosmology and ideas about the origin of the universe going from thousands of years ago up to, the 1960s, I guess, when the Big Bang was sort of firmly established.
Mm-hmm.
So then we go into inflationary cosmology, and then in the early 80s we get these quantum cosmologies from Hawking and Vilenkin. Then we say, okay, but these aren't coming from a real theory of quantum gravity. In the mid 80s, the two biggest candidates for quantum gravity theories, string theory and loop quantum gravity, were proposed. And in the sort of end of the 90s, early 2000s, people started doing cosmology with them. And what they consistently seemed to find was that the Big Bang was not the beginning. So we talk about those. We talk about models coming out of where the universe comes out of a black hole. We talk about an alternative to inflation called variable speed of light theory. We talk about cyclic. There's been a revival recently of cyclic universes. Penrose is the most famous case, but he's not the only one. Um, and we have, of course, holographies, very hot topic in physics. So we talk about holographic cosmology. And then the last sort of category of models that we examine are ones with a time loop. So we could imagine that the universe is something like the movie Groundhog Day. Um, and those have been seriously proposed, and there's some reasons to take them seriously, although, of course, they're speculative. And then the last two chapters, we talk about the interaction between science and religion. We talk about the Kalam cosmological argument, the fine-tuning argument. And then the very last chapter, we try and bring it back down to earth by saying, well, how are we actually going to test any of these crazy ideas? Because science
Hmm.
requires us to test these models if we're going to sort of accept them into our, if you like, cathedral of knowledge, the things that we accept
Hmm.
as being true.
Hmm.
Um, so we talk about, real telescopes that are being built right now and fantastical ideas for telescopes that may be built in the future. Who knows? It's all a question of, whether the public actually wants to build and fund this stuff. But potentially we could build a telescope that, in some sense can see all the way back to the Big Bang and then tell us what happened. I mean, it wouldn't be seeing in a visual
Right,
medium, and not through light, but there are other ways to do it. Yeah.
right, right.
So that's a basic summary of the book.
And your co-author is came over from Iran
That's right.
in
Yeah.
the end of 1999, I believe it was.
Yeah, about then. Yeah. Yeah.
And he was studying cosmology in Iran. Is that correct?
Well, he did his undergraduate degree in physics in Iran, and then he did his PhD in cosmology at Princeton.
Princeton. Okay,
Yeah,
okay.
and then a
But
postdoc at Harvard. Yeah,
a very I think a fair treatment of the field as it is today. Um, and
thank you.
it's not, and it seems even with the religious section, I know he was from a Islamic background, but he's not a practicing Muslim. Is that correct?
No, oh, sorry, that is correct. Yes, he
Okay,
was
yeah.
he was a practicing Muslim and no
I
longer
did
so.
I did detect some sympathy, though mild, to theism there. He could at least understand why theism is an appeal to people. But
Yeah,
you
that's
you
right. Yeah,
talked about, let's talk a little bit about inflation, because that is the big thing on the table, and
that's right.
there are a ton of varieties of inflationary cosmologies. But this all started with Alan Guth in the 1980s, who was puzzling over the flatness problem, the uniform temperature of the cosmic microwave background radiation. I'm not exactly sure what the exact nugget was that caused Alan to create inflationary models, but he was trying to explain an anomaly in the current Big Bang paradigm. Could you go
That's
into
right.
that a little bit?
Yeah, sure. So actually, the anomaly that he was trying to explain is one of the ones that actually not many people talk about so much now. So the ones people talk about are, as you say, like the flatness problem, the horizon problem. We can go over what they are if you want. But the problem he was actually trying to address was something called the monopole problem. So if
Yeah.
you think about a magnet, magnets have like a north pole and a south pole. And if
Hmm.
you cut them in half, you don't get one half having a north pole and one half having a south pole. The half still has a north and a south pole. So,
Hmm.
so these are called dipoles. So that's what every magnet you've ever come across is a dipole.
Hmm.
But weirdly, the sort of particle physics that was being entertained at the time seemed to predict that at the Big Bang, there'd be an enormous number of what are called monopoles. So
Hmm.
magnets with only one pole. And that was a problem because we should detect them, we should find them, and we don't see
Hmm.
any. Um, Also, they'd be very heavy, so it's hard to see how the universe could ever have expanded if there were these enormous number of monopoles. So they tried to cook up a way of sort of getting rid of the monopoles, and what they found was that a certain sort of phase transition in the early universe could do it. So that what that phase transition was is something called supercooling. And you can actually do this experiment in your home if you're careful enough. So what you need to do is get very pure water, put it in a bottle, and then put that bottle in the freezer. If it's pure enough, and if you're careful enough, the water will stay liquid, even though it's below its freezing point. Um, and this is called supercooling. If you
Hmm.
take the liquid out of the freezer and you shake it, it would very, very rapidly turn into ice. Um, but it can stay in this supercooled state. But it's unstable, right? Any little nudge, it'll turn into ice, which is why the water turns into ice in the freezer, because probably the water wasn't pure enough to start with, or you didn't place it in the freezer carefully enough. But you
Hmm.
can do this. So what they suggested was that there could have been a supercooled phase transition. And then the story is that Henry Ty, who was kind of the person that actually pulled Alan Guth in this research direction, was going away to China to see his family. Um, and he said, you know what, I wonder if this wouldn't affect the expansion rate of the early universe, this phase transition. Alan, go and work. Why don't you work on this whilst I go away? So Alan worked on this one night, and in a single night, he showed that it would cause an incredibly rapid period of expansion. And then he realized that it would solve another problem, which is called the flatness problem. And the flatness problem you will hear a lot in actually theistic atheistic discussions because it's
Hmm.
pulled up all the time in the context of fine tuning. Although they don't
Yeah.
call it the flatness problem, they usually say the force of gravity needs to be fine tuned by like 60 decimal places, but it's not really the force of gravity. Actually, it's how flat the universe is, um, and that yeah needs to be extraordinarily fine tuned to get us into the flat geometry that we have today.
Hmm.
But
Hmm.
what Alan Guth showed was that that's only true if you have gravity being attractive. If gravity is repulsive, which is what would happen in an inflationary scheme, it's not true. You could start anywhere you like and it will be forced into a flat geometry. So this claim of sort of 60 decimal places fine tuning is just not true in inflationary cosmology. It's the absolute opposite. You can start anywhere you like, and inflation will force the universe to be in a flat state. So that when he realized this, he drew like two boxes around his notebook and went, spectacular realization. This can resolve the flatness problem pointed out by Bob Dickey.
Okay.
Um, so then he got really excited about inflation. And then it turned out it could solve all kinds of other problems in cosmology as well. So then everyone else was like, oh my God, this is the most amazing idea we've ever come across. Um, and to this day, inflation is the prime sort of theory for the early universe.
Yeah.
Now,
Yeah.
it was thought to be something that would happen after the Big Bang. But what was realized was that actually inflation would cool the universe down to as cold as it can be. And then when inflation ends, because this is the period of exponential expansions, how the speed that we're talking about is the universe doubling in size every 10 to the minus 37 seconds. That's the sort of number
Hmm.
that you'll often hear quoted. So this extraordinary rapid period of expansion, when that ends, all the energy that's in the inflating space is converted into matter and radiation. And that is the Big Bang. So inflation happens before the Big Bang
Yeah, I've heard that. Right.
in
I've
our
heard that.
current understanding. But also the other profound feature of inflation is that it seems to lead to a multiverse. So it
Hmm.
seems to be a natural outcome of inflation. And this
Okay.
is where you get a lot of controversy, or it's not the only place you get a lot of controversy, but some people like the multiverse. Out of physicists, I would say sort of three groups. There's those that love the multiverse, those that hate it, and those that don't care. Um, they're like, well, does inflation lead to whatever? It works
Yeah.
in our
Right.
patch, and we don't care about all that.
Right.
Others are like, yep, no, this is a brilliant idea. We love it. How profound. Others are like, we hate it. This isn't even science. So in the book, we sort of go over the debates between the
Yeah, it was
different
good.
camps.
It was good.
Yeah,
Very good. So
and we
the inflate.
we try not to sort of stick our neck out and say this group is right, this group is wrong.
Yeah, you
Rather,
did a good job with that.
thank
Right.
you, thank you.
You
Yeah,
could tell that you were really striving for a kind of just kind of laying out the facts,
Yeah.
the state of cosmology today.
Yeah.
So with
Yeah.
inflation, though, Phil, whatever flavor of inflation
Mhm.
people are offering on
Yeah.
this requires something you described there. What I understand to be uh, this is associated with dark energy and the search or the hunt for the inflaton, what started inflation, what stopped inflation.
Yeah.
But the energy that you're talking about is directly related to a kind of reverse gravitational force. Is that the same as dark energy?
Ish. Yes and no. It is in the sense that they're both repulsive gravitational force. So you could say dark
Okay.
energy is just inflation.
Okay.
Um, but obviously enormously different scales.
Yeah.
Yeah. So in that sense, and so people wonder, is inflation linked to dark energy or are they just separate? And
Yeah.
that's still unknown. We don't really go into that in the book.
Gotcha.
But there are people who have proposed ideas that, maybe there are a few inflaton particles left or something like that. Um,
Are they
so,
looking for the inflaton, or is that just a
but
fantasy of
no, because that would
1980?
be not really because it would have decayed away. So
Yeah.
that's the whole point of inflation. We're not undergoing inflation now, except in the sense of dark energy. But
Hmm.
I think the idea of trying to say inflation and dark energy are the same thing probably is not that popular in the specifics. I mean, in a broad sense, they are the same thing because they're both this accelerated expansion. So in some sense, they're the same, and in other sense, um, they may just be different phenomena.
So there's for the lay people, so maybe that negative gravitational force is like the match, and then the fire is the dark energy from that match. Maybe I want to draw a really crude analogy that.
Something like that. Maybe you could say something like that. Yeah.
Okay,
But the
okay,
bottom line is, what I would say is that in Newton's theory, mass kind of determines gravity, right?
yeah, right,
But
right,
in Einstein's theory, so there's no way you can have negative gravity because unless you could have negative mass, that's hard to think about. But I can't. But in Einstein's theory, pressure is also relevant for gravity,
right.
and it turns out that when vacuum has energy, then you have a negative pressure term, so it
Hmm.
causes accelerated expansion. So, and that's just part of relativity. So
Okay,
there's nothing surprising about that in that sense.
all
But
right,
the question is, what value does it have? So for dark energy, it has a very small value. For inflation, it has a very large value.
gotcha, gotcha. And there is a you. I think you talked about this a little bit in the book, and we don't have to go into it because I want to get people discussing things here with you if they have questions.
Mhm.
Um, I recently had deep dived into Adam Rees, uh, uh, Adam Seiss, Rees or Seiss, I get
Adam
his
Rees,
name.
Adam Rees, Adam Rees.
Adam Rees,
Yeah.
um, Joe Dunkel, and Wendy Friedman,
Mhm.
who are all took different methodological measurements of the rate of cosmological expansion, what you would say would be associated with dark energy. And I don't know how much controversy or agreement there is in the field, but it seems, from what I was reading, that there are at least each of those individuals did three different kinds of measuring of the expansion rate and got three different answers. And what
That's
I
right.
wasn't sure about is like how controversial is that? Are they so close that people don't care, or
No,
is this
no, this is
That's
a
a big
big issue.
problem.
It's a
Yeah.
big problem. So this is called the Hubble tension. So basically,
Hmm.
there are different ways to measure the expansion rate of the expansion rate of the universe,
Yeah.
and they should all agree, and they don't. Now, at
Mm.
first, people weren't that bothered because they were pretty similar, and the error bars were quite big. So it was like, what's the big deal? So there's a number that describes the expansion rate, and one number had, I think, I can't remember now, 68 and a half. The other one had 72. And it's like, oh, it's pretty close. The error bars are probably a couple points. So whatever. But then what happened is that the error bars shrunk, 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 shrunk.
Mm.
And that difference didn't go away. And it's like now the difference is really big compared to the error bars. So now this is a big headache. So there's basically two broad ways you could interpret this. Either there's some measurement error somewhere, or there's some new physics, something new about the universe that we haven't learned. So
Mm.
there's a controversy as to which one it is. And we don't know. No one's found the error in the measurement. Like, what would be great if we could just say, look, there's an error in the measurement and here it is. And no one's found that. On the other
Mm.
hand, it would be great if someone had a theory to explain, oh, what's the new physics? And it all fits perfectly and it makes predictions and we can confirm it's true. That hasn't happened either. But it's going to be one of these two things.
Yeah.
Uh, and who knows? And then in the book, we actually describe a bet that Niayesh, my co-author, made with his supervisor, his PhD supervisor was David Spergel, and he was the lead theorist on NASA's WMAP satellite, which
Mm.
was a satellite to map the cosmic microwave background.
The one that
And
it came after Planck, right?
no, before Planck. Planck
Before
was the
Planck.
most
That's
recent.
right.
Yeah,
That's right. That's right.
yeah, yeah. So they had a bet, what's the most exciting thing in physics that's going to lead to a new discovery? And
Yeah.
David Spergel is betting on the Hubble tension.
Okay.
Other people are like, it's probably just a measurement error.
Yeah.
In fact, we did a survey of physicists on various controversies within the field, and the most popular answer was that it is a measurement error. But there's a
Hmm.
decent enough number of people that think it's new physics that it's an open question.
Yeah. So the to follow up with that,
Yeah,
I don't know the technical side of those theories. I mean, I read as much as I could understand,
yeah.
but it seemed like when I watched a video by Wendy, she's like, "Yeah, it's no big deal, really. I mean, it is a problem, but it's like we're close. There is an error problem there. It seemed like it didn't bother her that much, but of course, I don't know Dr. Friedman or her
Well, she's
work.
in the cat. As far as I know, her measurements sort of came out sort of like there isn't a problem. But of course,
Yeah,
other
that's what
measurements
that.
say there is. That's the whole
Yeah, yeah,
point.
that's
So of
right, right,
course, she thinks her ones are the right
right,
ones.
right,
You
right.
know. So, but others disagree. I mean, this is the thing, right? This is the edge of knowledge.
The
So
edge
where
of
we have edge
knowledge,
of
exactly.
knowledge, we have
Yeah, yeah.
disagreement, and we can make progress. And in fact, there are ways that we're gonna. I think we will have an answer to this question within.
Gotcha, gotcha. How do you think,
Seems to me, I
Phil?
remember in the book
Go
that
ahead, Tim.
there was a suggestion that the Hubble tension might be resolved by hypothesizing a decaying cosmological constant or a changing
Yeah.
cosmological constant. Is that something that a lot of physicists buy into, or is this just kind of early
More
stage?
more so now. So because actually there's been independent evidence for changing well, we can't say cosmological constant if it changes, right?
Yeah,
So you might say dark energy. I like to say dark energy because that leaves it open to whether it's a cosmological constant or not. Uh, so what has happened very, very recently, there's been a group called there was a group called Dark Energy Spectrographic Instrument, or that's their instrument, and they've done new surveys of dark energy, and they find with quite high significance, about 4 sigma, that dark energy is changing over time, which is very big deal if
Yeah,
true.
five sigma is like fact, isn't it?
I'm reluctant to say that. Like, first off, it's a bit arbitrary where you draw the line. Yes, 5 sigma is considered a discovery, but what I'd be cautious about is that even if they get to 5 sigma, which maybe they will within a year or so, um, we still have to wait for other teams to replicate the result,
Hmm.
right? So you
Hmm.
might remember people had discovered faster than light neutrinos with like I can't remember 6 sigma, you know, but it turned out, that it was an error. So
Hmm.
so don't get too hyped up about five. Of course, if they get to 5 sigma, it will be a big deal. But still, we want to see other independent measurements coming, getting the same
Sure.
values. But
Sure.
but the fact that they got that number is exciting. Like it's definitely very, very exciting.
Something there. Something
It's
there.
there's potential for a new discovery, but of
Yeah.
course, in physics, it's more often the case that when you get potential for a new discovery, it goes away, and
You're right.
it's just a measurement error or something like that. So you'd always bet on, unfortunately, the boring measurement error answer, but there's certainly signs for something changing in dark energy, and that would be very, very important.
Hmm.
Huge, huge implications. Also, for the claim about fine tuning of the cosmological constant, that would
Sure.
be seriously undermined in that scenario. But it's well, we wait and see.
Yeah. Does with the cosmological constant maybe changing or fluctuating to some degree in these measurements of expansion, Phil, how do they factor in, and this is a technical question that's over my head, but I kind of have it in my head. I don't even know if it's a relevant question, but how does the energy density problem, prediction versus observation on a quantum scale, factor into the dark energy and the constant measurement? Because I know that's the biggest gaffe in physics, as they say, is the measurement
Yeah.
versus observation. How do they
Yeah.
factor that in when they're measuring the expansion rate, or do they?
No, they don't. Like they don't go to like basically, as I understand it, uh, what they do is they try and work out the energy of empty space from quantum field theory,
Hmm.
and they get this extraordinary high number, and then they just measure, using like supernova or some other means or cosmic microwave background, the expansion rate of the early universe of the universe, and they're independent of each other. The problem is they don't agree by this 120 orders of magnitude.
Yeah, it's huge.
Um, but that calculation for quantum field theory is kind of assuming that the dark energy is a cosmological constant. But if it's
Mm.
changing over time, then it isn't a cosmological constant. So maybe like just forget that calculation. Just in the bin, that's not what we're observing. So the fact that they disagree is no big deal because they're not, one isn't the other. So this is why it's very exciting if it turns out that it's
Do you
not a
feel like
cosmological constant.
cosmology today, modern cosmology today, is in a position on the verge of a, because it seems like your book does detail a kind of fervency to
Yeah.
find an explanation. Because there are, I agree with you and your co-author, Nayeshi, is that how you say it? Nayesh?
Niayesh.
Niayesh.
Yeah.
There are problems with Big Bang cosmology. I think in apologetics, I will just say for myself, you tend to oversimplify things for the sake of a wider audience, without really having a detailed background understanding of how ever changing the field of physics and cosmology actually becomes, especially in the theoretical realms. So
Yeah.
I'm hesitant to say that, oh, look, Big Bang meets Genesis, perfect, because I think myself personally, I think I found myself in agreement with some of the problems that you both point out with current Big Bang cosmology, and thus the fervor to find some other explanation that might sort of fill in the holes. But in terms of the idea of this, when we're talking about cosmology, it's a relatively new field in terms of science in the last, what, 100 years since Hubble, if we want to say that's kind of when it
Something like that.
started.
Yeah. Yeah.
Um, Phil, what do you think? How important has observational astrophysics become to a field that seems to have a burgeoning sense of theory being more important than actual observation? Now, that may just be my own bias speaking, but it seems like the more abstract, like I was watching one of your videos with Dr. Penrose, a recent one, and it just seemed like, he himself has changed his mind in just the last few years about some of the things that he has postulated in the past. I kind of laugh when he says, well, don't read that book,
Well,
because it's
he said,
like,
don't read the appendices, not read the book.
don't
Yeah.
read the
Yeah.
appendices. Yeah, yeah.
Yeah. Yeah.
But,
No, but
and you,
that's
and
normal. I mean,
what do
in
you, what,
physics, when you're developing a theory, it morphs,
yeah,
So that's normal. Nothing different. But to answer your question about what's more important, like theory or experiment, I mean, to me,
exactly. Yeah.
they have to go together. So theorists dream up ideas, and then the idea is that the data starts constraining what those ideas are, you know.
Hmm.
So
The Baroque corners,
yeah,
as you put in the book.
yeah, exactly.
Hmm.
Yeah.
Hmm.
That's exactly right. So you
Mhm.
can always dream up some way of saving a theory, probably by making it more and more Baroque. But then hopefully people will say that's too Baroque. I'm not going to believe that. We'll
Hmm.
accept the simpler version of the theory, maybe. But maybe, if you add bells and whistles to a theory to try and save it, if you have independent justification for those bells and whistles, maybe that's okay. So it's an evolving process we call it a dance between theory and experiment. Sometimes
Hmm.
the theorists lead, and the experiments follow. And sometimes the experiments lead. The data comes in, and the theorists have to reconfigure things to accommodate that data. And hopefully, eventually, it all converges on one theory. Um, so that's the process of science.
Gotcha. Could you
Well,
lay out, Ken, you have a
better
question? Go ahead.
is it a better than 50-50 chance in your mind that we will winnow down some of these theories in the next, I don't know, in our lifetimes, like let's say the next
I
30 years?
I hope so, but of course you don't know whether nature's going to be kind or not. So
Mhm.
so one of the things that we want to look for are primordial gravitational waves. This is going to be the key to
Mm.
sort of unlocking these. And but we don't know how strong they would be if they exist at all. So um, if they're strong enough, we could detect them tomorrow. But we just don't know how strong they would be if they're even there. And some theories say they're not there, So what we have to do, so what is going to happen, I think, here's what I think is definitely going to happen. Um, we are going to understand dark energy better. I think that's for sure. We're going to solve the Hubble tension. That's for sure. That's all going to happen in the next 10, 20 years. We're going to look for the primordial gravitational waves. We may or may not find them. That's very uncertain. We're also going to do surveys of galaxies, and that can also reduce some of the parameter space. Um, so that's definitely happening. Um, we're going to launch LISA, which is a huge project to do gravitational waves in space. That might give us more information about quantum gravity. Might not, because we just don't know whether nature's going to be kind or not. It's a bit like asking, are we going to find a planet with life on it in the next 10 years, 20 years? That who knows? We don't know how frequent they are. If they're common throughout the universe, we're going to find them. If they're rare, we might get lucky, we might not, you know. So it's really hard to say, but we can definitely point to areas where there's going to be very clear progress,
Gotcha.
and we'll see what happens.
Phil, question that comes up, you follow apologetics, so I'll mention the Borde-Guth-Vilenkin theorem. Because
Border-Guth-Vilenkin theorem.
Borda-Guth, I can't thank you
Yeah,
for pronouncing. I read people's
okay.
names and I think I know what they are, but Borda-Guth-Vilenkin,
Border-Guth. Yeah.
Borda. Okay. Thank you for sharing that. All this time,
I'm getting
you
that from Alan Guth because
okay.
he pronounced it border, so I'm
Borda.
pronouncing it border.
Okay.
Yeah,
Okay.
yeah.
Now I'll just be a layman's version of my understanding of BVG. I'm not going to steel man the physics. I can't. But basically, it was Vilenkin and Guth and Borda that said that any universe in a state of expansion, which I think ours would qualify, is not past eternal. But that's not exactly, as far as I understand Alan's clarification on this, not past eternal doesn't mean hard stop beginning, correct?
All right, so let's try and clarify let's give some context to this.
Yeah.
So what happened was that in the 1960s, Roger Penrose and Stephen Hawking proved these theorems called
Hmm.
singularity theorems,
Right.
which showed that the Big Bang would be like the beginning of time. But these theorems have assumptions in them. And one of them is that gravity is always attractive, roughly speaking. It's a bit more technical, but that's roughly speaking right. Um, Now, inflation is repulsive gravity, so it violates the Penrose-Hawking singularity theorem. Also, inflation is eternal, or is thought to be eternal. So once it starts, it never stops. It always creates more and more universes. So if it's eternal into the future, what they were trying to answer was, is it eternal into the past? Does the fact that inflation violates singularity theorem means there's no beginning? Or do you do you still have a singularity? So
Hmm.
those are kind of two twin questions, if you like. And what they argued was that inflation actually wouldn't still need a beginning. It couldn't be eternal into the past. So if there's some you would need inflation by itself then wouldn't get rid of the singularity. It would just push it further into the past, like at the beginning of the multiverse, if you like. Um, that doesn't mean there is a singularity, and it doesn't mean there is a beginning of time, because there could be other ways to get rid of a singularity. And most people think a theory of quantum gravity would get rid of a singularity.
Hmm.
Roger Penrose thinks that switching to what's called a conformal geometry will get rid of a singularity. So Border-Guth-Vilenkin does not, even if valid, does not show the universe had a beginning. What it shows, at best, is that inflation had a beginning. That inflation is
Okay.
future eternal, but not past eternal. Or you could put it another way and say, if you want to get rid of a singularity, you're going to need something other than inflation to do so. But
Gotcha.
there's plenty of other things other than inflation that could do so.
Well, and
Um,
I think that's the problem you point out, Phil. I think in your book,
yeah.
Ken pointed this, Ken, you want to read that quote, Ken?
So I guess there's a thread going on, a discussion thread in this Zoom meeting, and there is a claim that Guth uh, was a advocate of a beginning of a universe, that the universe had a beginning. But then I recalled having read something about it in the book, and I just found it and I pasted in the quote. It's from page 362. It says, in 2005, Lincoln did say that the theorem proves a beginning to the universe, and Guth and Borde were mostly quiet about its implications. So for years, Craig, this is William Lane Craig, the apologist,
Yeah.
and his followers, not all Christian, would parrot the same quote from Vilenkin, ecstatic that their faith had seeming support from science. But they might have been wiser to follow Lemaitre's advice not to mix science and religion, lest changes in the former should embarrass the latter. Sure enough, when Craig stepped into the ring with Sean Carroll to debate God and cosmology, blah 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 blah, was able to deliver a superhero move that shook the core of the argument when he quoted his former postdoc supervisor Guth, saying, "I don't know whether the universe had a beginning. I suspect the universe didn't have a beginning. It's very likely eternal, but nobody knows." The revelation that Guth was a past eternal universe advocate was a devastating blow, as Craig had staked so much on the Borda-Guth-Vilenkin theorem as proving an absolute beginning.
Yeah,
So
I think that
Phil,
sums it up really well. Yeah.
what has Alan said publicly since that theorem has been put forth? What is his kind of official
sure.
position?
Can I
Oh,
say something
Yeah,
here?
go ahead, Richard.
Go for it.
Well, I know that in YouTube videos when Guth is being interviewed, and these are fairly recent, I think 4 years ago or so, he says, yes, there's a beginning. So I don't get this conflict.
No, I don't think
Quoting
that's right.
Guth
I mean,
directly.
I've interviewed him several times,
Mhm.
and even more, and in recent times, I did a debate with him and Roger Penrose, and he thinks there was not a beginning to the universe, but he's not sure. He
Oh,
doesn't claim to know. He's like,
okay,
that's where I would bet. Now,
I understand what you're saying, but
yeah.
I posted the YouTube video. You can search Alan Guth, did the universe have a beginning? And
Oh, it might be an old video that's
Could
been
be an old one.
reposted
four
because
4 years ago, 4 years
it's
ago,
is it on Closer to Truth?
Is it closer to truth?
I'm uncertain of if it's
Because
closer
Alan
to
has,
truth.
I will say
Because
in Phil's defense that Alan has changed his mind, or
yeah.
he has, or I will say this. I understand that Alan has nuanced the BVG much more than before when it was originally published. In other words, he's clarified things and actually has changed his mind, like Dr. Penrose himself on a few things, has actually changed his mind on the theorem a little bit. Now, Vilenkin, Phil, Vilenkin stood by, has he stood by the conclusions that the paper has put forth, or has he changed his mind too?
Well, all I can say is he wrote that in 2005 when he said it proved the universe. So
Yeah,
Alan Guth did say, was in the universe had a beginning camp. Um,
he was there at one point.
he was there at one point. So what I suspect, the video, I haven't seen it, so I don't know. But what I suspect is that that's an old video that was reposted because since probably 2010s, Alan Guth has been in the universe probably eternal into the past position. And he's maintained that position. Well, the last time I spoke to him was about 2 years ago, I think, and he was still in
Hmm.
that camp.
Okay.
Um, and he even sort of defended the view that it could be past eternal. And in fact, when we were writing the book, we had this quote where he says, in fact, when one time I interviewed him and I was like, you and Penrose actually agree the universe is past eternal. And he goes, yes, yes, but I agree with that phrase, but no further, because he doesn't agree with Penrose's cyclic model, right? He's got a very
Yeah.
different conception
Right.
of what a past eternal universe would look like. Now, Vilenkin in 2005 wrote this paperback book, and he made this quote: "The universe, BGV proves the universe had a beginning." So I interviewed him. I can't remember what year it was. I think it was 2018. I'm going to guess. I can't remember. Something, give or take a year or two. And I sat in his office and I asked him, well, what does this theorem prove? And he said, it simply proves that inflation has a beginning. The universe as a whole, it doesn't say that. So that's what he said to me.
Okay. But if inflation has a beginning, then there's a beginning.
Not necessarily, no, because
Well,
they
if
could be.
inflation has a beginning, there's a beginning. How can you say inflation has a beginning, but there's not necessarily a beginning?
Because there could have been something before inflation. When you say, let me just clarify what you're saying, right? When you say inflation has a beginning, then there's a beginning. What do you mean? There's an ultimate beginning, like beginning of all space time,
Yes,
beginning to everything. Is that
that
what you
is what
mean?
Alan Guth was saying, at least when he made this video that I'm talking about. Yes.
Right.
The
Now,
Okay.
ultimate, the ultimate beginning.
I do not know when the video was first created. I know it was posted 4 years ago, and it seems very recent.
I mean, you could probably tell what Alan Guth looks like if he looks quite young, that it's not recent.
He doesn't look very young. He does
Well, that
not
is
look very young.
okay. I mean, I have to see it, so I can't tell you. But all I know is, last time I spoke to him was I think it was about 2 years ago, and he was definitely in that camp. So 4 years ago, if he said that, it must be old. It must be because I spoke to about more recently than that. In fact, even as we were going to press on the book, I was corresponding with him. I didn't speak to him like person to person, but I was emailing him, and we were clarifying like various quotes that are in the book, and he was making sure he was happy with them. And for sure, that was his position.
Okay. Then I have another question. If a
Okay,
scientist says we have proven this mathematically, which is
yeah.
what Guth said when he made the video, and well, he did it before that in the science journals, and then you find out it's not true, then what does mathematic proof mean for anything else?
Well, I think always I'd have to examine the quote. Like in the paper, the Border Goose Vilenkin paper, there's nowhere in that paper where they said they proved the universe had a beginning. They don't say that in the scientific journals. Now, Vilenkin did say it in a popular paperback book, and yeah, people like people make hyperbolic statements in paperback books sometimes. But he doesn't say that when he didn't say that when I asked him. Now, to go more generally, any proof of any theorem is always only as good as the assumptions. You can't have a physical theory that doesn't have any physical assumptions. It just doesn't make sense. So you have to basically say, well, what are the assumptions? And now, in the case of Border-Guth-Vilenkin, one of the things that happened is it's not the only thing that's happened with regard to this theorem, is that there had been a proof that the universe could not undergo what's called a bounce. And in fact, Alan Guth was one of the authors of a proof that you couldn't have what's called a bouncing universe. So just think of the universe contracting, then expanding. But that proof was in general, didn't use quantum gravity. So then what happened was quantum gravity theories came along. People started doing cosmology with quantum gravity theories because that proof was back early 80s. And then string theory and loop quantum gravity and others came along and said, oh, no, you can have a bounce. And they're in quantum gravity. So it doesn't matter what you say in general relativity. So whenever these proofs are done, they always have assumptions. This follows from this assumption. But you can always question the assumption. And that's always open to you, like in any physical proof.
Bill, could you not now, you don't have time to do it now, but in the future, could you search YouTube to see the video I'm talking about? Search
Well, why
YouTube.
don't you post a link and then we can have a quick look?
I did.
Find the video. Did you post the
Well,
link
I
in the
didn't
notes?
post a link, but I posted how to find it. You search
Ken, you can
YouTube
hunt it
for
down if you want to
Alan
hunt it down.
Guth, did the universe have a beginning? If I'll try to get a link.
I'll tell you
Okay.
what, why don't I do it right? Why don't you find the link? Come
Ken
back
will
to
look.
us.
Ken's going to track it down. Ken will
Okay.
track it
And
down.
then we
Okay.
can examine it.
Yeah, yeah.
Okay.
Phil, let's jump into this. You
But
do
hang on,
have
can I just
Sure.
one thing about this?
Fire
Even if
away.
Guth, like what we point out in the book is that there's a lot of controversies in the early universe that we are not settled.
Alan, one of the
So-
great perennial
No,
questions.
that's
Yeah,
closer
that's
to
closer
truth.
to truth.
Straight
Yeah,
away, I
that's,
know that's closer to
yeah,
truth.
that's closer to truth.
That's it. And look at the 7-minute mark, or maybe
Okay.
6:58. I don't know.
Hang on, I'm gonna click on it. We may hear it. One sec.
That's okay.
Straight away, that's old. I know that's old.
Ken, do you
'Cause
have
I
it? I
could
can
see-
share Ken's screen.
Just look at Alan Guth. He looks super young compared
He
to
does
when
not
I
look
interviewed.
super young to
That's
me.
You
10 years ago.
Compare it.
That's 10
it
years
to,
ago.
Compare it to when I had an interview with him.
I think that was 2015 when Closer to
That's
Truth.
But that video is old. I can see
That's an old
straight away
video.
from Alan Goo's face that it's old. Yeah.
2015, he's not even old, but okay, he could have changed his mind since then.
In 10
Well,
years,
but
physics theories have life like cats and dogs. It's like it lasts, they age quickly.
but I think
Yeah,
I
I
think the
know for
larger
sure that's
point,
old. But the
larger
larger
point
point was don't get hung up on what one individual scientist says,
Yeah, that's the thing.
right?
That's the
That's the
thing.
point. That's the more important point. Even if Guth did and still says the universe definitely had a beginning, so what? Right?
Well,
There's a whole diversity of different cosmologists and have different views about this. And at the moment, there's no experimental data that can decide this question that
but the
I'm aware of.
majority of cosmologists accept inflationary theory as opposed to all these other theories.
Okay, but even if you, well, so first off, we've done a survey on this. So we surveyed not cosmologists, but it was at a black hole conference. So we did this, what's called the Copenhagen Survey on Fundamental Physics. And we asked the physicists a whole bunch of questions on contemporary controversies within the field. So they're on all kinds of things within physics. So like, what's the best interpretation of quantum mechanics? What's the best candidate for dark matter? Things like that. What happens to information when it falls into a black hole? So we asked them about inflation, and inflation was certainly the winner in terms of it's the most popular theory, but it didn't actually get majority support. Now, to be fair, that wasn't cosmologists, they were black hole physicists, but that is a pretty adjacent field. And the people there were like leading experts in the field. Now, we are opening this out to a wider audience. So we may have a different answer, but then there probably won't be experts in the field. Now, I agree that if you ask cosmologists, well, we don't know because we haven't done it. But if you ask cosmologists, yeah, I think the majority would say inflation is right. So I definitely agree with that. But even if inflation is right, well, okay, so what? It doesn't mean you can't ask what came before inflation. So let's give an example in loop quantum cosmology, which is, you're taking one of these sort of quantum gravity theories, you're applying it to the Big Bang, and they say there was inflation, but before inflation was a bounce, and then you would have had a contracting universe. So it's even if we all agree inflation's right, it wouldn't tell us whether the universe had a beginning or not, because there could have been a bounce and then inflation. That's perfectly logical. There's no problem with that. So we don't know.
Phil, let's get into, we got about a half hour left, and
Okay.
I know I want to get into some of the theological issues that
Sure.
that come about with this. And I think
Yep.
we've got a nice working discussion going on here about the nature of, and I am in Christian apologetics. That is what I do
Sure.
for a living.
Okay.
I am a Christian. I've been a Christian for 32 years. I believe Jesus is Lord. But I love science. I love cosmology. I have a fascination with the universe like you do, Phil.
Yep. Yep.
But I have learned over the years that I'm not very smart. And a lot of these theories that you talk about in your book are extraordinarily nuanced in terms of mathematics, probability, physical observation, telescope time, who gets time on the LIGO, who gets time on the Hubble, who gets time with the James Webb, who gets time at the Large Hadron Collider. So there's a ton of stuff that is just kind of goes over your head for lay people. And I think that may be somewhat of an intimidation factor for people to step into the ring and have these discussions. But I will fault my own discipline for maybe putting too many elbows and putting too much stock in science as a means of backing up or proving. I don't like to use the word proof, but we're leaning too heavily on a field that is constantly changing its theories, its observations. The James Webb has opened up some mysteries. There's a third astronomical object that has flown into the solar system. They call it 3I. I forgot what the 3I, what's the name of it, but it's an
Atlas.
3I Atlas. It's the third interstellar object.
I think.
Cosmogorov.
Yeah.
What was the other one? The first one we had
Oh,
Oumuamua.
Oumuamua.
What
Yeah.
was the one before that? The Russian who had found it.
Oh, can't remember.
But
Yeah.
there's all this stuff out there
Yeah.
that we don't know. And there's a lot of things that maybe we do know that seem pretty solid on the scientific fact. But I think for me in Christian apologetics, I think, my job is to put forth what I believe is the truth about Christianity, God, and Jesus. But in terms of my belief, I didn't know anything about science when I became a Christian, but I was convinced that the universe had a beginning because of Genesis 1:1. In the beginning, God created the heavens and the earth.
See,
But
I
I'm
don't
kind
think
of,
Genesis 1:1 even says there's a beginning to the
yeah.
universe.
Well, so what my question would be to
Yeah,
kind of go into that theological point. Let's camp there, and why don't you explain, if you could do two things,
yeah.
explain what you think traditional Christians actually believe about that, and then explain why you don't think that's true.
Well, okay. So the idea that the idea that Genesis describes the beginning of the universe evolved. Like it wasn't. I don't think it was the Jewish position. In fact, rabbis debated it. You can actually see debates
Hmm.
between ancient rabbis about whether the beginning was Genesis or whether. So basically, you can think of two pictures, right? One is that God creates the universe in Genesis 1:1 from nothing. The other is that actually he's just sort of reorganizing. He's imposing order on a chaos. Um, so that's a second interpretation. Now, it's reading, like I was brought up Jewish and I did learn Hebrew. I'm not good at Hebrew now, but
Bereshit barat Elohim et hashamayim va'et haaretz. That's the only Hebrew I
yeah.
know.
Okay. Okay. So
Genesis 1:1.
problem is, yeah, to translate that. So some people translate as in the beginning God created the heavens and the earth, right?
Hmm.
But there are other translations which is like when God began to
Right, I'm
create,
aware of that. Right, right.
right? And there you can't know this just from reading those words, right? It's interpretation.
Hebrew is a little obfuscating sometimes. It's not exactly clear because we don't have a comprehensive understanding of some of the terms
Yeah.
in like the
But
book
the
of
other thing
Job.
is, but the other
Go
thing
ahead.
is those words Hashemayim and Haaretz. So I take those to mean the land and the sky. And the reason I say that is because Aretz means land. Like if you grow up Jewish, you'll be singing songs about Eretz Israel. So you
Hmm.
know Eretz means land.
Hmm.
And there's plenty of times they talk about going to the land of Egypt, to the Atlantic Ocean, blah, blah, blah.
Yeah,
And then the Hashemayim,
the
is also
heavens,
where
the
well,
sky.
it's also where the birds fly. You could just say it's the
Yeah.
sky. So
Hmm.
you just as you could say in the beginning God created the heavens and the earth, you could also say when God began to create the land and the sky. Right now that looks a much more well, it's a very different picture of what we're
Well,
talking
and I
about.
think too, a lot we have centuries, if not millennia, of a developing, burgeoning science of the universe that really wasn't formalized. You could argue Kepler, Newton, Galileo,
Yeah,
500 years ago. So I would agree with you in terms of the hermeneutic and the etymology of what you have in Genesis 1:1 that
yeah,
you cannot import planetary or modern astronomy into
yeah,
ancient Hebrew words. And so
correct.
I'm of the position, I think, that it is the sky and the earth. But I will also add to that, I think that nothing that we have uncovered actually fundamentally alter. If you want to interpret Genesis 1:1 that way, what we find in the sky and what we find on the ground, I don't think anything is for Christians. I don't think anything is fundamentally changed. God is the creator of it all, whatever he's saying there in Genesis 1:1. So the earth, I would agree, because the earth, that's all they knew. Hebrews didn't know the concept of round planets floating in the sky on Newtonian gravity or Einsteinian
Yeah,
fabric.
they didn't know about
They didn't
galaxies,
have that
right?
stuff, right?
Yeah,
But then
right.
as we go down into Genesis, we see, I like think it's day four, or before day four, that God creates the rakia, which he separates water from water.
That's day 2 or 3. It's not day 4.
Well, the rakia day four is when the stars
That's when
and all this stuff. Yeah,
the
before then,
stars
so
are
he
on day
creates
4.
this,
Yeah.
what I would call space. Now I know there's a lot of debate about the rakia being solid because of
Oh,
Jerome's Latin translation of
the
rakia.
Rakia, no, the Rakia is definitely solid. There's no question about that in my mind.
Okay, so let's say that there's the separation of the water, so that we actually have God creating on day four the sun, moon, and the stars that go into whatever the rakia is, because I know that
They're
the
placed into the
concept,
Rakia, yeah.
yeah, the concept is that the solidity of the rakia is the stars, the moon, and you can look at cathedrals and see the same kind of thing. These things are embedded into the solidity of
Yeah, you got
whatever
to
it
remember
is.
what the ancient conception of the universe was. Forget the Bible.
Yeah.
Just what did the ancients believe? They believed generally. I mean, obviously, it's sure different people have different beliefs, but they thought that the dome, the sky was a solid dome. Everyone in ancient world believed that. And why did they think that? Well, probably because they look up at the sky and it's blue. So they thought there's water, and the water comes down from the sky. So there's water up there, but it doesn't always come down from the sky. So they thought there's like holes in the rakia, the firmament,
Hmm.
and when they open up, the water comes down. So you see this in the flood story. They say the gates opened up in the firmament. The waters are separated. All right. So they're separated by the firmament. So it has to be solid, right? And there's other passages when Moses and Aaron go up to visit God, they're standing on, they call it lapis lazuli, which is a blue crystal.
Yeah.
Um,
Crystal Sea.
and there's another passage, I think, I can't remember, is it in Job, where it says it's solid as a crystal. I can't remember what it is. Solid as molten. I can't remember what it is now. But there was no one debated in the ancient world that the firmament was solid, right? There's just no question that it was solid.
Now,
Um,
from the Bible's account,
yeah.
I know the word rakia is used to like hammering out of a shield or
That's
a
right.
mirror.
And in
Yeah,
fact, that explains why they thought the sky was a dome, because they thought it's hammering out of a bowl, actually. It's
yeah.
the root of the term is to hammer out a bowl. So
Now
that's what they
there's
thought the sky was. It was a solid bowl.
now there's an interesting parallel, I think, to the creation narrative that God does on Earth. I don't know how widespread this is, but I know you don't believe it actually happened. But if you look at the separation of the water in the
Mhm.
Exodus, where God literally separates the water. There's no physical mechanism that separates the water. And then between the water, the separated water, God places the children of Israel and they cross over on dry land. And so to some degree, if you look at what God tells Abraham in Genesis 15:5, that your descendants will be like the stars. Count the stars if you're able. Your descendants shall be just like this. And so then we move to Exodus, and God has set his love on these people and has rescued them from Egyptian bondage and slavery, separates the waters, and then takes Abraham's descendants and puts them between the waters. And so I think you have a kind of a visual there for what creation might have been. But obviously, we've gone to the moon. It doesn't seem to be embedded in anything solid. We visited distant worlds. It doesn't seem to be embedded in anything solid. So, regardless of the solidity idea in Scripture, we don't actually directly are told by God that, like, when Jesus was judged, he was judged in Pilate's place on the pavement. We're not told in Genesis exactly that rakia is necessarily solid. So do you think, I know you find that the Genesis narrative is mythological, but could you at least understand why it seems, because to me, the biggest thing from that I draw from science in relation to solidifying my faith are two things. One is the intelligibility of the universe. That we can do cosmology and physics at all seems to be a kind of a wonder. And then, and as we wrap up here, we can talk about, because I know you've talked about it extensively, how, if God exists and he created everything, why is there so much widespread suffering? And so for me, it's not an easy answer, claim that it's going to answer everybody's questions. But I think that for me, it doesn't answer all my questions, but it does show that basically, the book of Job, where Job gets questioned by God, where were you when I created the heavens and the earth? When I found the foundation of the earth? And I think what happens in Job, that what you have in Jesus is a reversal, that God takes Job's place. God takes our place in the person of Christ. And so there's, the sufferings of Christ. And I think that for me, at least, says that God suffers with us as his son. And it doesn't answer all the questions. It doesn't answer all the why questions that people bring up about animals and cancer and disease and devastation. But why don't you just kind of give your position on maybe the intelligibility of the universe,
Okay, yeah.
what God might have to do with it or not, and then how you see suffering fitting into a cosmology with or without God.
Yep. All right, so let's take the first one first, intelligibility. So it's certainly true that, we can describe the universe with like simple equations and stuff. So and of course, people have wondered, how come? Isn't that incredible? And some people might point to that as evidence of God, like he wanted us to understand the cosmos. My problem with that is, and it is the old joke, and I'm sure you know this joke, but it is the farmers go to a physicist. And they're like, we want to get a high yield for our cows. They're not giving us enough milk. So the physicist, give me a week and I'll see if I can work on something. They come back after a week and they say, okay, I've got a solution, but it only works for spherical cows in a vacuum. So, what the point here?
Luke
Uh,
Barnes just told me that joke recently.
okay. The point here is that these elegant equations and descriptions work in very idealized situations. The real world is incredibly messy and very hard to model with the mathematics.
Hmm.
And there's plenty of stuff that we can't model with mathematics so
Oh,
far. I
sure.
mean,
Sure.
and like earthquakes, no one's got any kind of mathematical formula to predict an earthquake. So why is it that there's a mathematical formula to predict an eclipse but not an earthquake? Eclipses are pretty, but of course we've learned things from eclipses, but like relativity was proven with an eclipse, but we could have done it without the eclipse because there's other tests of relativity. So it seems to me that there are some things that are intelligible and some that are not. So I'm not sure uh, what this theory, if a theory could say, I can explain why some things are intelligible and some aren't, then I'd be quite impressed with such a theory. But to just retrodict the sort of the explanatory neatness of things afterwards seems a bit like a cheat. And also, if God has free will and God can do anything, I don't know why that we would expect the universe to be intelligible because, every miracle that he does makes it less intelligible. So how many miracles he's going to do? Well, of course, you might say, well, only very occasionally. But there's no prediction of how many he's going to do. So in which case there's no prediction of how intelligible the universe is going to be. I would say if the universe is just governed by its laws and nothing else, um, without a God, then there's no surprise that there are mathematical laws that govern the universe. I mean, what else would you expect? I mean, think of it this way. Some things are just necessarily the case. Like there's an equation that describes the mass of the Earth compared to the mass of the moon, right?
Hmm.
Mass of the Earth is 6 times the mass of the moon. And you could rearrange that equation. The mass of the moon is 1/6 the mass of the Earth. That just has to be the case, right? It's just necessarily true. Couldn't be otherwise, right? And maybe some of these other things, are like that. We don't know, but who knows? So I don't find that the intelligibility of the universe to be a persuasive argument for God.
Okay.
Um,
Do you think
so
then, just an addendum to that, I
sure.
won't push back. I just wanted to
No,
know,
no, go for
do you
go for it.
think the laws or the math or however you want to coin that, if God doesn't exist, are you suggesting that these have actual causal properties, that they can make stuff?
Well, okay, so there's different views on laws. So one is they're descriptions only,
Hmm.
but there is another view which is no, they're more than descriptions. They do have what's called governance. So
Okay.
they actually, a photon moves in this way because the laws of physics force them to. They compel them to. So I think we don't know, but I am very reluctant. If a lot of people say, well, laws can create things because laws are just descriptions. I'm like, and I asked Valenkin this because Valenkin is of the opinion that
Yeah.
laws do create things. I mean, ultimately,
Right.
if you ask
Right.
Valenkin, what's the ultimate core? He might not use the word cause, but reason why the universe
Hmm.
exists. He'll basically, well, I have asked him this, so I know the answer. It's the laws. He thinks the laws do create things, and Guth, I think, is
Hmm.
sympathetic to this view as well.
Okay.
And maybe that's right. I mean, I don't know that it's right, and I don't have the view that it is right, but I don't
Hmm.
know why people like Craig just rule that out and scoff at it. It's perfectly conceivable, and I think there are some arguments that it's true. Um, I won't have time to go into them now, but there are reasons to take that view seriously. So I'm open-minded, is what I would say
Okay.
So
about
could
that.
it be
Okay.
that the laws in that case serve functionally the place of God? In other
Yeah.
words, it's swap
Yeah,
out
that's what I was
God
getting at.
laws.
Yeah.
Yeah. In a sense, yes. Maybe the laws are actually necessary. They couldn't be otherwise. That's a possibility. And maybe they are creative, that they actually cause the universe to exist in some sense. Conceivable. Why not? I like that better than God because I think that we know the laws exist in some sense. Now, in what sense are they, descriptions only, or are they actual sort of causal agents, or a causal agent in the universe? I say agent very loosely there, just as something that brings something about rather than a person. Um, but we know the laws exist in some sense, whereas I don't think we know that God exists in some sense. I mean, it might.
Roger has Dr. Penrose has I know this maybe has changed, but I know he believes that laws or mathematics themselves, to some degree, somewhat similar to Max Tegmark. They have an independent existence in a Platonic realms that actually has a causal kind of a property
Yeah, I
to
think
them.
basically, yeah, this is Platonism, right? I mean, it's a
Yeah.
form of
Hmm.
Platonism,
Yeah.
or some variation on it. It's not exactly what Plato
Right.
suggested, but
Right.
it's
Right.
something like it. But yeah, and Penrose is definitely a mathematical Platonist in
Yeah.
that he thinks
For
that
sure.
mathematical objects are real.
Hmm.
They're
Hmm.
not just sort of tools that we use. You know,
Right.
other people have different interpretation of mathematics.
Yeah.
They would say no, mathematics is created by humans, and you know it's just a useful tool. And the Platonists, mathematical Platonists, would say no, mathematical objects are real.
Right.
I
Right.
don't know if he thinks that laws
Or
are
maybe I'm mixing it
platonic
up with Max
objects.
Tegmark. Tegmark thinks there's that
I
math
mean,
actually.
let's put it this way: this view that laws are creative is something on the table that I don't know that we can rule it out. Let's put it that way.
Okay.
I'm trying to relate that to what Graham Oppie mentioned. He was on our club for a couple of appearances, I believe.
Yeah,
Three.
Talks about necessary, like necessity as
yeah,
being like the foundation of everything. And I couldn't get my mind around what he really believed. I asked a couple questions, but it just blew
yeah.
my mind. I didn't understand. It's like it had to exist and it had to cause all of this stuff. So is that a form of Platonism, would you say, or is that different?
I think that's slightly different because there's a question of is there something abstract that exists? And I think that I would call that we're calling that Platonism here. I mean, it might be slightly different to what
right.
Plato said, but you know, is there something abstract like the laws of physics that like or mathematical objects that really have their own existence? So that's what I would sort of describe as Platonism in
I
my
think
very.
Ken, yeah, I think Phil's onto it. The idea that necessity, philosophically speaking, I'm not a philosopher, of course, but Phil, you can doink me if I'm wrong because I know you have philosopher friends. But
I got a philosopher
um,
friend. I'm not a philosopher either, but yeah,
well, you can
yeah.
ask him.
I mean, I just
Um,
interview like experts. Like
you
that's
get,
me,
yeah, I'm the
right?
same way. That's just all I
Yeah,
know. All my knowledge
right,
comes
right, right.
secondhand.
Yeah,
But Ken,
yeah,
I think necessity, philosophically speaking, is just that looking backwards, we're here, and as Phil said at the beginning of the broadcast, something weird happened 14 billion years ago, if that's your time scale. And so whatever that thing was, event, cause, abstract law, that is the necessary object. Because we're here,
well, it
something,
doesn't have to be, but it doesn't have to be necessary. So I would distinguish between, you know, whatever it is you're saying is like at the base of your explanatory chain,
yeah, yeah,
right?
yeah.
But that doesn't have to be necessary.
Okay.
Necessary means it couldn't have been otherwise. It
Couldn't
could
have been
be
otherwise. Couldn't have been
that at
otherwise.
the
Gotcha.
base of your chain of reasoning, there's something which some philosophers call a brute fact.
Yeah,
That
yeah,
it didn't
right.
have to be that way. It just is that way.
It just is that way.
So,
Right.
so that's a brute fact, and that's a possibility as well, right? It might be that at the base of reality, it's just a brute fact, and that it just there is no more explanation. You know, you just stop. You know,
Yeah, right.
that's possible. You know, I don't want to like Sean Carroll's very keen on that, and
He's a
he's
brute
like,
factor. Yeah.
yeah, and he's very strong on it. It's like there has to be brute facts, and I don't agree with that, but I'm open to that. There might be brute facts, right? And I
Hmm.
think so. We should distinguish between the Platonic ideal that there's some abstract thing that exists, and then whether it's necessary,
Okay.
that it had to exist. Maybe it did. Maybe the laws of physics are abstract. They exist. They have their own sort of Platonic existence. Maybe they are necessary. They couldn't have been otherwise. But it could be. They could have been otherwise. They did, but
So
that's
there's
how it
four.
is.
You could be a Platonist and not believe in necessity, or
Yeah.
you could be a necessitist and not believe
Yeah.
in Platonism.
Yep. Yep. Yep.
Hmm.
Yep.
Hmm.
They're all on the
Yeah.
table, right? Yeah.
Gotcha.
Yeah.
Gotcha. All right. We got about 15 minutes, Phil. I know it's a meaty topic. It always comes up in the book club.
Okay.
I know fine tuning wasn't really part of your book as a whole. It comes up a little bit in snippets,
Yeah.
but I wanted to talk about, and I know this topic really didn't fit into your book, but Nayeshi, did I say that right again?
Niayesh.
Niayesh
Yeah. Yeah.
had talked a little bit about his own experiences and suffering and what he went through in Iran. And so there's a couple of ways to look at suffering. One is theologically, and one is, naturalistically.
Yeah.
How do you see? I know it's a big question to wrap up
Yeah.
here on, but
Sure.
God suffering or naturalism and suffering in relation to cosmology, because really, as it all just boils down to what we're going through on Earth as we look at the heavens. So
Yeah.
from a particularly theistic point of view, what do you think some of the problems are, and maybe some of the challenges for suffering in a naturalistic worldview? And then we'll just kind of wrap it up
Right.
there.
Okay. Yeah. So, we've advanced an argument. This is not me and Niayesh now. This is me and some others, Ken Williford, David Woodralph, um, in particular, Perry as well. But we've advanced an argument which we call the expanded problem of animal suffering. So you're all familiar with, the fawns in the forest, and this is, the problem of animal suffering.
Hmm.
Um, and what we say is that the problem of animal suffering is much worse, particularly for the Judeo-Christian theist. Well, I should say probably the Abrahamic theist. Um, the reason it's worse is because not only do animals suffer, but also there's been hundreds of millions of years of animal suffering before humans ever existed. Also, the engine of our creation seems to be like evolution and catastrophes, like, the meteor impact that wiped out the dinosaurs and so on. On top of that, you've got violence towards animals in the Bible as well. And then on top of that, we've got this sort of mass extinction event that's happening because of humans, and it could easily have been alleviated by God making us vegans or something. So we point out a whole bunch of problems so that's why we call it the expanded problem of animal suffering, because usually when there's discourse on the problem of animal suffering, they don't mention any biblical texts. And we're like, no, let's bring them in because now it's going to get even worse. So we think this is a strong argument against the biblical God.
Okay.
Now, of course, there's back and forth about this. It does interact in some sense to the fine-tuning argument, because there's a sort of parallel between the two. Because one response you could have to suffering is to say, but we don't see all of existence. So maybe what you see is not the whole story. And if you saw the whole story, this problem of suffering would go away. That's called skeptical theism.
Hmm.
There's a parallel here to the fine-tuning argument, because the fine-tuning argument sort of says, well, where we look, we see fine-tuning. But hey, you can't search the whole probability space. That's impossible, right? You
Yes.
couldn't vary all the constants and every imaginable possible law all at once. So it could
That's
be
Tim
that,
McGrew's argument. Tim McGrew and
yeah,
Lydia McGrew argued that. Yeah.
yeah,
Hmm.
exactly, right? Um, so it might be that we are looking at you're in a desert and you're saying, okay, where's all the water? Wherever we look, we see desert. But if you zoomed out far enough, you'd find actually the whole planet is mostly water, right? So again, so there's a counter to the fine-tuning argument that says you can't really see everything; you only see a bit, you know.
Yeah.
And so these two arguments sort of can run parallel to each other.
Hmm.
Um, and so they kind of interact in an interesting way. But from my own view, is I think we're more confident about the fact that animal suffering is real than I am that the fine-tuning problem is real,
Okay.
and that there isn't a naturalistic explanation, even if it is a real problem, which is not really clear. One thing I should add very quickly is that we did the survey of physicists, as mentioned, and we asked them about fine-tuning. And we gave them how many topics? We gave them these answers as possibilities. One was the constants are just brute facts that need no further explanation. So you
Hmm.
don't need multiverse or intelligent designer. They just are what they are, and it doesn't need any other explanation. So that was one. Another was that the constants are explained by an intelligent designer. Another is that they're explained by a multiverse. Another is that they're explained by necessity. Um, and then we had other and don't know. So the most popular single answer was brute facts. Needs no
Hmm.
further explanation.
Hmm.
Interestingly, the philosophers did a survey and they got the same most popular answer. For us, the second most popular answer was multiverse. And also we had Darwinian explanation for fine tuning
Yeah, I
because
read
it,
that one today. Yeah.
yeah.
Hmm.
So, because it could be the universe is reproduced and then you get a Darwinian selection mechanism. So the Darwinian, so I think I can't remember exactly the numbers, but it's roughly something like this. About 30 something percent were like brute facts, no explanation needed. About 20 something percent was multiverse. About 10% for both necessary and Darwinian explanation, and 3% for intelligent designer. So
Yeah. So
that's
it's definitely a minority position within the field of physicists who are not theistically prone per se. I mean, I know there's even some theists that are opposed to it,
well,
like
what's
Hans
interesting.
Halvorson too, right?
Yeah,
Uh,
no, but what's interesting is if you survey physicists, I don't know what proportion are believing in God, but it's higher than 3%. So there's no survey I've ever seen that got that number lower than 3%. I think I remember one where it was something like about 40% of physicists believe in God in America,
Hmm.
or USA, I should say, compared to about 70 something percent of the population. So if you take the population as a whole, it was something like 70 to 80% believe in God. Then you go to physicists, it was something like 40%. Then if you go to, or maybe it was scientists, I can't remember exactly. Then if you go to members of the like National Academy, like the elite scientists, then it's about 7%.
Hmm.
So where our survey result was like 3%, you know,
Hmm.
so it seems that there's fewer physicists would think that fine tuning um, is explained by an intelligent designer than believe in God.
Yeah, and
Gotcha.
the book
Um,
gives a
Gotcha.
good example. Halverson, I think you've quoted.
yeah,
Yeah, Hans
Halvers is a great
Halvorson. Yeah,
example.
he's got a good.
Yeah,
He's got at least the. I don't agree with him, but I think his explanation is at least lucid. You can at least
yeah,
understand why. Um, all right,
yeah,
we got about
yeah.
5 minutes, Phil. I just
Okay,
want to
yeah.
kind of leave you with. I mean, I know from our exchanges in the past and watching some of your videos that you're not friendly to Christian theism, and I'm not screaming at you about that,
It's
but
okay.
I think a lot of what you're what for me as a Christian, I'm just gonna, and then
Yeah,
feel free to comment. You have the last word. That
yeah,
I think what the remarkable thing about the Christianity is in terms of what we have in the New Testament, I think, is that if it's true, then the the cross on that cross was the one about whom Isaiah prophesied, the suffering servant. Now I know the servant in Isaiah is a problem because people think that the servant is related to Israel, but I think the servant in Isaiah 53 specifically is a guilt offering, and it can't be. It can't be. But anyway, I'll just leave it with this: that Jesus on the cross is the man of sorrows who died for my sin and yours, and this is the same one who wept with Lazarus, who ate and broke bread with everybody. I can't imagine that people would have come up with this on their own. And so for me, the remarkable where you see fine tuning and suffering meet is right there on the cross, and then finally the resurrection. I think that is the greatest hope for mankind. I think that's for me how I combine it. I mean, it doesn't answer all the questions that I have about the universe, and I have many,
yeah.
or
Sure,
about my own
sure.
personal suffering, and I have
Yeah,
many. I don't have
yeah,
all the answers, but I think for me, emotionally and intellectually, as one who's wrestled with depression all of his life, I think I find the most surprising and shocking. I mean, I'm an adult convert, meaning in that the universe was created by the very same one who came and lived and dwelt among us. So I'll leave it there, and you're
yeah.
free. You got 5 minutes to wrap it
Okay,
up, and then maybe throw in some advice for Christians and atheists about this very interesting topic.
okay. Real quick then. Okay, first off, if you've had depression and Christianity helps you with that, then I say great, go for it. You know, I hope it helps you, and I hope you overcome that. So I'm all for
Thank
that.
you. Thank you.
Now, um, let's see.
I threw a lot at you. I'm
Well, yeah, you
sorry.
did. Okay, that's okay. I'm trying to
Not
remember
very fair of
the
me to do
points.
that.
That's okay. That's
I don't
okay.
know if we heard the end of his comments about suffering. I was waiting to hear what he was
Yeah,
was gonna be on
I
that.
know he was running out of time, so I'm
Yeah, yeah.
sorry I
Well,
railroaded it in that direction.
basically,
But
I was saying that suffering, I think, yeah, animal suffering is a particularly strong argument against the existence of God. And you can read our
mhm.
paper, The Expanded Problem of Animal Suffering, or
It's
you can
online
watch
for
it.
free. Yeah.
It's online. And also, we did a YouTube video on it, so go on my channel and look at animal suffering. And in fact, Michael Murray, a famous Christian theologian that we were criticizing, has just replied to us. So
Oh,
we're
great.
going to reply to him.
Great.
But anyway, okay. So you are like people wouldn't make this up. I think they would make it up. I don't think they just made it up out of whole cloth. My
Hmm.
personal view of what happened was, I think Jesus existed. I think he was a charismatic preacher. I think people followed him like they follow other charismatic figures, like they're following Donald Trump today or Scientologists. You know, people
Hmm.
follow charismatic people. Um, I think they invested a lot in him and then it didn't pay out. Like he got crucified. And so what happened was they had to find a rationale as to why when you invest your life into a cult, And then there's been studies on this. Like the sociologists actually infiltrated an end of world cult, and it had a prediction for what date the world was going to end, and then it didn't end, and they were really curious to know what would happen. Would the cult just disband? Would they ignore it? Would they say, "Oh, we were wrong"? They didn't say, "Oh, we were wrong." What they did was they found some reason why they were right all along. They've confabulated. So what I think is, maybe one or two people maybe had a grief hallucination, something like that, and then they thought, Jesus is still with us. So they thought, this explains everything. Why he died on the cross, it actually makes sense. Whereas before, it didn't make sense. They made sense of it. And so this idea of a sacrifice, and they fit it into the sort of theological ideas that they had. So I think that's a much simpler explanation than a man actually rose from the dead. Maybe people had false memories of events that didn't happen, but basically some mixture of maybe false memories, grief hallucination by maybe one or two people, and then the confabulation that comes with that, like, suddenly they felt it made sense. That to me is a much better explanation for what would have happened, 2000 years ago. And I don't see that someone else suffering is very helpful for our suffering. So the example I gave on our podcast was, imagine the doctor says, I've got good news and bad news. The bad news is you've got cancer. The good news is I've also got cancer and I'll be suffering with you. I just don't see that that's good news at all. That's just more bad news.
I think in the Christian narrative, the doctor's suffering, the great physician's suffering, takes away the consequences of it doesn't overcome the death, but it takes away the consequences of a second death because of our moral failure, which the Bible calls sin.
I don't see that makes sense, because if you deserve a punishment, you should have I don't see how someone else, like if someone is a mob boss, right, and they've ordered someone to go and do a hit, and then the FBI come and arrest them, the assassin can't say, I'll take the time for the boss. I'll do the 20 years, the 30 years. No, that just doesn't seem to make sense. Like, you can't, I don't think you could substitute someone in that. If we are deserving of punishment, someone coming along and say, I'll take it on me, I just don't see that it makes sense. That's not justice. That just isn't.
I would agree with you that I couldn't take, if you did something wrong in the UK, I couldn't fly over there and stand in a court of law for you on your behalf and take your guilt. I agree with that. I think the difference there is that if God decides that this is what he wants to do for us, that makes all the difference in the world, because he created us. Anyway, it's 2:30 your time.
Okay.
You need to jet. Do you have any bullet point
All right,
advice for us?
I'll just sum up. I'm not going to talk about suffering and Jesus and so on. Let's go back to the book. I think the book, and I hope you agree, is super exciting.
It's very well written. Very well written.
Thank you. So if anyone is interested about what is actually going on in cosmology, about trying to understand the Big Bang, where we are and where we might be in the future, read The Battle of the Big Bang. And hopefully, it's a fun read. We try to make it interesting and not just have like dry science, but the personal journeys of scientists as they sort of struggle with this issue. And I think that makes it readable. And
definitely for sure.
So check the book out, and I'll leave it
very, very educational for me to read it. I thought I knew something about the Big Bang, but I knew nothing, and now I know even less, I think, because
there was a review. There was a review. I can't remember. It was some physics. Was it Physics World? I can't remember. And someone said a book where you end up realizing you know less than what you started.
Yeah, I had that same feeling too.
Might seem like a failure, but actually it's a success, because what you want to do is challenge what we think we know.
Well, thank you, Phil. You've been a gentleman and a scholar. A great book.
Thank
Good
you.
job.